Hi, everybody. This is Kristina Abbey with Talking Glass Media. I'm here today with Dr. James, Professor of Meteorology from Embry-Riddle Aeronautical University. Welcome.
Thank you so much. It's nice to be with you.
We're excited to have you here and to talk about monsoon season and explaining what monsoon is to our viewers and listeners.
That's great.
And
yes,
some safety tips.
My favorite topic. So the monsoon is actually more technically the North American monsoon that affects the southwestern United States. And the word monsoon actually comes from an Arabic word, Monsoon, which means season. And it's really a seasonal wind shift in the winds from a prevailing west wind to a prevailing south or southeast wind during the summer months, typically late June to September. And it has a dramatic impact on our climate here.
So that's what monsoon is. Okay. So why do we see similar weather patterns each year?
Well, because it's a very consistent part of our climate where the winds will very consistently every year will shift as a result of the continent getting hotter than the oceans. And this causes moist air from the tropics to move up into the subtropics and even up into Arizona. And as this diagram shows, the monsoon is really like a big sea breeze. So maybe you've ever lived near a coast. You probably recall that around the mid-morning hours, the winds shift and come onshore from the cooler ocean. And the reason for that is because as the sun heats both the ocean and the land heats up faster. And this causes there to be high pressure in the upper atmosphere over the land. And then it causes that airflow to move out over the ocean aloft, which causes then high pressure at the surface, forcing the cool air from the ocean onshore. So this is what happens along a coastline. And you can have lake breezes or sea breezes in many different climates. But then think of the monsoon as a much larger and even a three-dimensional sea breeze. And I have a diagram to show you here of the prevailing wind during June is typically from the southwest across Arizona. And the wind from that trajectory tends to be much drier, partly because the Eastern Pacific is much colder ocean water than the Gulf of Mexico and the Gulf of California. So that brings air from colder water tends to have less moisture in it. But then also it has to travel over the coastal ranges of California and the Baja to get here if it comes from the southwest. And that will lift the air and remove some of that moisture on its way here.
So it's drier and warmer.
And so it's drier, warmer air.
Okay.
And so that's during the end of our, in the peak of our fire season in Arizona, when we have that dry, hot June weather.
Where we start seeing all the restrictions and precautions for
safety.
And
those restrictions can start as early as April each year, depending on how dry the fuels are out there. And then in July, what's interesting is that the high pressure builds up into the Four Corners region. And so you can see that in the diagram, the lines are like isobars, and then the arrows show the streamlines. You can see that high pressure builds up towards the Four Corners region, and there's a clockwise rotation around the high, which brings moist air from the southeast up into Arizona, or from the south.
Okay, and I'm going to backtrack a little bit. What is an isobar?
Oh, sorry. Yes, an isobar is a line of constant pressure. So typically in the upper atmosphere, the winds go parallel to those lines.
Okay.
And so as that high pressure builds, then it brings that moist air up into Arizona. And it also helps to change how the winds are structured with height. Those are important to organizing thunderstorms, the way that the winds are shearing or structured with altitude. So I have a little schematic to show you about how the monsoon really looks like, and it's actually in three dimensions here. So the high pressure that I showed you is in the middle or upper part of the troposphere, maybe 15 to 20,000 feet above sea level, and it tends to get situated up over the Four Corners region, but it can meander around in different locations. But in the lower atmosphere, we have a low pressure which sets up over the Colorado River basin and towards the northern Gulf of California. And that rotates in an opposite direction, and counterclockwise. So that brings moist air in the lower atmosphere northward to the east side of that low. And then we have moist air coming up from the south or southeast in the upper atmosphere. Some of that also comes from the Gulf of Mexico. And so it's a very three-dimensional structure here. But it all results from the fact that the continent is hotter than the ocean during the summertime, and it happens every summer. Mm-hmm. And so it's a very consistent phenomenon that occurs here. Some monsoon seasons produce more rain than others. And so we give them the nickname of nonsoons when they don't produce much precipitation.
Right. Oh, those are always the ones that I go, oh, come on, give me a little more rain.
It's such an important part of our climate here because, it doesn't really contribute that much to our water supplies, to our reservoirs, to our groundwater, because a lot of that rain that falls during the summer will quickly evaporate. And it's very localized or spotty, but it's so vital to keeping the vegetation and the fauna alive here in this area during the summer. And so it's really an important part of our climate.
Very interesting.
Yeah.
So when we see the monsoons, what are some typical weather events we might see with a storm?
Okay, so typically the thunderstorms that form here are usually of a smaller scale than what you see over the Great Plains. They're usually, just maybe a few miles across in diameter. They tend to trigger over the higher terrain first because we have thermal circulations that flow up the slopes, and they tend to converge in the higher peaks or around the higher terrain.
So that's why we see monsoon storms earlier in the day in northern Arizona, but later in the day in the Phoenix area.
Exactly. So They tend to start over near the San Francisco peaks, the Mogollon Rim, which is that steppe in the mountains between southern and northern Arizona. And we're actually south of the rim, but we have mountains around Prescott. We have the Black Hills to our east and the Bradshaws to our south, kind of circling up to the west of the city. And those are actual hotspots for thunderstorms as well, that they tend to initiate where the rising motion is. And then as they become organized, if the wind is shearing just right, if the vertical distribution of the winds is favorable, then those storms start to organize and propagate down towards the lower lying areas, the flatter terrain, and towards the deserts of Arizona.
Okay. So, and like with, we'll often see like a flash flood warning, and there's no storm overhead. Why is that?
It's a great question. So a flash flood warning indicates that there are intense flows through a particular watershed or in a particular area. That doesn't always require the rain has to be right overhead. It could be falling upstream within that watershed, and that water could be rushing through those areas. So it depends on a lot of different factors. How moist the soil was when it started raining. Sometimes if there's have been some prior wildfire conditions or some burned soils, those tend to run off the water much more quickly. So the Weather Service is going to issue a flash flood warning much more readily when those conditions are present. So.
Okay. So I know those monsoons, with any thunderstorm, really, there's always that watching out for things like lightning, making lightning safety, again, flash flood safety. I hear terms microburst or downburst, and I don't really understand what those are. And what's the difference between that and a funnel?
Okay, great question. Yeah, we have a lot of different hazards and impacts from these storms. Most of them tend to be fairly benign. Most of the thunderstorms we have here are what we call air mass thunderstorms. So they tend to develop and then dissipate within a half hour, an hour. And so they mostly just produce rain and maybe small hail and some gusty winds. But under certain conditions, they can be more impactful. When we have very unstable and air with maybe some dry air in the lower atmosphere or dry air in the middle atmosphere that mixes with the storm. Anytime you mix dry air with a thunderstorm, you can have what we call a microburst. So a microburst is where evaporatively cooled air from the evaporation of the rain and the cloud accelerates out of the base of the thunderstorm towards the ground. And it can reach speeds of over 60 miles an hour downward or more. And then when it hits the ground, and then it can spread outward and become very turbulent. So not only is it hazardous to people on the ground to produce very rapid development of strong winds, but also to aviation. We've done some recent research on the Arnell Hill fire, and there's been significant evidence that a microburst may have occurred just to the east of Yarnell in that event, and that might have contributed to the winds and made it very difficult to fight the fire.
Because it produces high winds, and they're generally straight winds versus the rotation of a tornado or a funnel.
So that's how a microburst is. So it has a downdraft and then outflow.
Okay.
So they are straight line winds. Now, tornadoes can form here. They tend to be fairly weak compared to the plains and somewhat rare, but they can develop. And this occurs when the thunderstorm somehow is able to start to rotate. Oftentimes as air flows around terrain, that can cause rotation. And then if a thunderstorm forms, it amplifies that rotation and creates a rotating updraft. And that updraft can then further amplify to where the vortex can descend from the cloud to the ground. But that's a rotational wind, and the rotational winds tend to be much more maybe localized with a small tornado, but they can be very hazardous.
Okay. Well, thank you for sharing some really interesting weather information. Going into monsoon, what are some tips of what people can do to remain safe following some weather safety?
Well, and I didn't mention that two of the most common hazards we have here are certainly the lightning and the flash flooding that you mentioned. So there are different precautions for each of those hazards. For example, with flash flooding, you certainly want to stay away from low-lying areas, and you don't want to drive through any roadways that are covered by the runoff, because you have no idea how deep that water is. And just 1 cubic foot of water weighs 62 pounds. And so a rushing stream can certainly lift a vehicle, even if it's 6 or 8 inches deep. And then there's also the hazard of lightning. Lightning is where we have discharges from static electric fields that build up between the thunderstorm and the ground, or within the thunderstorm itself. And those discharges tend to develop where we have more conductive objects, especially taller objects. So you're going to want to stay away from power lines, plumbing, especially copper piping, anything that's electric devices that are connected to the power grid. And the real safest place to be during a thunderstorm is indoors in a fully enclosed building or in a fully enclosed vehicle. And it's not the rubber tires that spare you from the lightning in a vehicle. It's the metal cage around you that protects you.
Okay.
So that's what's good for lightning. Tornadoes really should be in an interior room, although it's very rare to see damage to homes and so forth with tornadoes during the monsoon. Right. We don't have the kind of shear in the winds that they have over the plains to create that. But microbursts are very common here, especially early in the monsoon, where it's dry and hot, but thunderstorms, high-based thunderstorms, are still forming out there. That means there's a long path for that rain to fall through hot, dry air for it to evaporate and cool and then produce that microburst. So it's good to be indoors during those, especially the early monsoon events that produce those damaging winds.
Stay inside. Don't chase the storms. Leave them alone. And just be safe. One of the things that I've heard as a popular misconception is that if the storm's not directly overhead, that lightning can't get you. But it can, even if the storm's not directly overhead.
That's right. So the lightning channel can certainly extend up to 5 or 10 miles outside of the thunderstorm.
So shooting off the side of the storm, it can still go quite a ways then.
That's right. So a good rule of thumb is if you can hear the thunder, then you're close enough to the thunderstorm to maybe take cover.
Okay.
Another thing we haven't talked about is hail.
Oh, yes.
And hail can be very destructive as well. We had a hailstorm last summer that produced up to golf ball sized stones on the north side of town. And so typically if the thunderstorm has particularly dark base to it, or maybe even a colorful appearance to it, sort of bluish or purple, it may have a larger hailstones within it because it scatters the light a bit differently.
Really?
So, but just any dark cloud base means that you have a strong updraft. And so that's something to be aware of as well. You should be indoors for sure with a hail situation like that.
Okay.
So.
All right. Well, this is a lot of great information. I really appreciate your time today. And so, yeah, just be safe this monsoon and keep an eye out. We'll have a monsoon forecast coming, and we'll share that out with our readers as well.
Great.
Thank you, Dr. James.
Great. Thanks. It's been good to be with you.